Hi, today is Monday, March 4th, 2025. I just came to work about 20 minutes ago or 25 minutes ago, and I'm trying to read this interesting article coming from Seoul, Korea. Currently, I live in Seoul since I am Korean. I work for Korea Telecom KT, the number one cloud service provider and number one carrier in Korea, I think. So if you do have any IT businesses, or if you want to set up your branch office in Korea or headquarters, even headquarters in Korea, you are welcome, and I will give you free consultation as regards to your voice and data needs and cloud requirements. This article is about cancer cell. I don't have cancer, and I won't have cancer anymore in the future because I am doing what is called anti-cancer touch walk. You can check out how the walking is done on my YouTube channel, Hyungsam Park or KT Park. Park here is PAHK, and also simultaneously put in anti-cancer touch walk or power walk or touch walk. You can check. You can learn how it can be done easily. With that special technique, you can get rid of your current cancer situation, and also you can prevent any cancer growth, right? So it's quite easy. If you want to learn more about it or do it with me for a month, for a week, for one session in Korea, you are welcome. I will charge you a minimal amount of expenses for my time, right? Since I'm a KT employee, I cannot charge you more, and it's out of friendly gesture. Just you pay for my time, right? I would like to see the results, right? Results-oriented person. Okay, so let's check out interesting epochal development from Korea, right? My own country. And what happened? Cell and tech.com. This article is from celland.com, and it was just advertisements, maybe. Reward in 2 seconds. Close. Okay, so I was stooped by the advertisements. The title is Korean scientists develop a technology that converts cancer cells into healthy cells. This article is from healthfood.thebustednews.com. Korean scientists develop technology that transforms cancer cells into healthy cells. Full event guide. Okay, Boston, Massachusetts. I've been there once, Boston. Cancer remains one of the leading causes of death worldwide and continues to be a complex challenge for modern medicine. Despite advancements in treatments such as chemotherapy, radiotherapy, and immunotherapy, these methods often come with severe side effects, right? Severe side effects, and in many cases, limited effectiveness. Now, a team of Korean scientists has developed innovative technology that could change the paradigm of cancer treatment. Based on cellular differentiation regulation, this groundbreaking approach has demonstrated the ability to revert cancer cells into healthy cells, offering a revolutionary therapeutic strategy with fewer side effects than conventional treatments. A revolutionary approach to cancer treatment. The study published in Advanced Science introduces a computational model called benign Boolean network inference and control, designed to identify key regulators responsible for cellular differentiation. So there was a call from my colleague, right? By designed to identify key regulators responsible for cellular differentiation. This approach allows scientists to manipulate cancer cells and guide them back into a non-malignant state. By applying benign to transcriptome data of human intestinal cells, researchers identified that inhibiting these specific genes, MYB, HDAC2, and FOXA2, induced the differentiation of cancer cells into normal enterocytes. This discovery was validated through in vitro and in vivo experiments, demonstrating that the combined inhibition of these genes significantly reduces colon cancer proliferation and promotes healthy cell regeneration. So they inhibited something, right? So this model is designed to identify key regulators responsible for cellular differentiation. This approach allows scientists to manipulate cancer cells and guide them back into non-malignant state. So I think they just use the identifier, right? Identifiers for cancer cells and regulated them, like reduce some elements or increase some elements. Then the cancer cell regulators or identifiers, they just change their attitude, change their characteristics, like a sex transformation operations. You become transgender, right? You become a man, suddenly you become a woman, maybe gradually here. Interesting take on the cancer cell therapy. Benign artificial intelligence in biomedical research. The success of this research lies in the application of artificial intelligence and mathematical modeling to decipher the complex genetic regulator networks involved in cancer. Benign reconstructs gene regulatory networks from single-cell data, identifying expression patterns that can be modified to induce a healthy phenotype. This model not only identifies key genes in cancer progression, but also predicts optimal strategies to reprogram malignant cells into functional differentiated cells. Its application is not limited to colon cancer, but could be used for other cancer types and diseases related to abnormal cellular differentiation. The mechanism identified by Korean scientists focuses on regulating genes that block cellular differentiation. Interesting. MYB, HDAC2, and FOXA2 have been identified as master regulators that prevent cancer cells from completing their differentiation cycle. So MYB, HDAC2, and FOXA2, if they are regulated, if they are inhibited, then the cancer cells cannot go further with differentiation cycles. So I guess even though I am not a genetist or genetics scientist, probably we can infer that the cells first grow as normal, right, as with other cells. But gradually it starts to change its characters, change its sex, right? Then it becomes male or female. I don't know. I don't want to be I want to be politically correct here. Let's assume they're male, right? Their male cells become cancer cells. So by inhibiting the male hormonal growth in those three regulators, then the cells become females, right? With a lot of females, males don't have to compete with each other. They can get to have a lot of sex. They can date a lot of girls, right? 3 wives, right? Instead of just 1 wife or no wife. So everything is good. So basically, this one is based on the Asian or Arabic cultural thing, right? In Arab, you're allowed to have up to 4 wives. Muhammad, I think he had 8 wives, right? He was a very kind, very generous person, and he was enlightened by the Gabriel and the God. But in Arab, 4 wives are allowed. So probably this one has some cultural background in Asia and Arab. There's no particular words, expressions that I would like to remember, but regulators, right? Some 3 genes, MYB, HDEC2, FOXA2, MIB. They were responsible for regulating cell differentiation. So in the future, I would like to read about cell differentiation cycles. Thanks for listening. Bye-bye. Have a wonderful Monday, Monday-titis.